Welcome back to Nginx Advanced Mastery, Lesson 02, where we turn Nginx into your backend's shield. In Lesson 01, we made Nginx fast. Now, we make the backend survive. The trick is micro-caching. Hold dynamic responses for just 1 to 10 seconds and watch your database load drop by 95%. We'll get there with 4 directives: cache.path, cache plus valid, cache.lock, and use stale, and 3 real-world patterns built on top of them. So let's lay out the 4 pieces. First, proxy a cache path, declared at the HTTP level, defines the zone, where files live on disk, how they're sharded with levels they're 1.2, and how much key memory you allocate, where 10 megabytes buys you roughly 80,000 cached items. Second, proxy uncache and proxy uncache not valid activate that zone inside a location and set per status code TTLs. Third, proxy uncache not lock is your herd control. One request fills the cache while 1,000 siblings wait. And fourth, proxy cache use stale. The single best line for resilience serves stale content when the backend errors, times out, or is being refreshed. Now, those 4 directives only make sense once you understand the lifecycle they operate on. Every cached request lands in exactly one of 5 states, and Nginx tells you which through the upstream cache.status variable, log it, because you'll read it constantly when debugging. Miss means first request or expired key, fetch from backend. Hit is the happy path, fresh, served straight from disk. Expired means TTL passed, refresh now, and this is where lock matters. Stale is your safety net firing when the backend fails. And updating means another worker is already refreshing, so serve the old copy and don't pile on. With the lifecycle clear, let's anchor everything on the directive that actually defines the cache. Proxy, cache, path. It lives at the HTTP block, never inside server or location, and it splits responsibilities cleanly. The keys zone is shared memory holding metadata, roughly 80,000 keys per 10 megabytes. The path on disk holds the response bodies. Max size caps disk usage and triggers LRU eviction, inactive evix entries nobody has touched, and the rule that saves you later, 1 zone per use case, APP, static, API, never shared. Now we activate that zone inside a location with proxy cache, and we tune time to live per status code. Cache 200s for a minute, 404s for 10 seconds as a negative cache, and barely touch 500s. 1 second is enough to absorb a burst without pinning a bad response. 2 gotchas to internalize. If you serve per-user content, append cookie session to the cache key so users don't see each other's data, and always ignore set cookie from the backend. Otherwise, Nginx will refuse to cache anything for a logged-in session. And log upstream cache status. That's how you actually see hit, miss, and expired in real time. Logging cache status sets you up to spot the 2 failure modes that quietly destroy production: the thundering herd on a cold key and the backend going sideways while a TTL expires. Proxy cache lock fixes the first one. When 1,000 requests arrive for a missing object, exactly 1 goes upstream and the other 999 wait, then drink from the cache. Proxy cache use stale fixes the second. On errors, timeouts, or while another worker is refreshing, Nginx serves the last known good response instead of propagating the failure. That single line turns your cache from a performance trick into a resilience layer. With the directives in hand, here are the 3 patterns that cover almost everything you'll actually deploy. Pattern 1. Microcache. A 1-second TTL with lock on dynamic pages collapses traffic to a single backend hit per URL per second, and that alone can drop database load by 95%. Pattern 2. A 10-minute cache on a slow-changing product API because the catalog doesn't update every request. Pattern 3. Negative caching. 30 seconds on 404s, so bots probing for admin.php hit your cache, not your backend. Same machinery, 3 TTL strategies. Pick the one that matches the endpoint and paste it in. Pattern 1 deserves its own slide because microcaching feels wrong until you do the arithmetic. A single page view fires 10 to 50 backend requests, so at 100 requests per second on the same URL, a 1-second TTL means the backend sees one and the cache absorbs 99. That's a 99% reduction from a TTL shorter than a blink. Pair that with cache lock and use stale and Nginx, becomes a circuit breaker. The cache outlives the backend, serving stale content while your origin recovers. And none of it matters if you don't log upstream cache status. Measure the hit ratio, tune the TTL, repeat. So here's the cheat sheet. Print it, pin it above your monitor. The top 3 are non-negotiable. Proxy cache, path defines the zone, proxy cache wires it into a location, and proxy cached valid sets your TTLs per status code. Add cached lock and use stale, and you've got the herd protection and failover we just talked about. The bottom 2, custom keys and ignore jocked headers, are for when your backend sends set cookie on responses you actually want to cache. 7 lines, production grade. Theory's done. Now you earn the hit ratio. 3 drills, all built on a deliberately slow Python backend that sleeps 2 seconds before responding, because you need to feel the gap between miss and hit in your bones. Exercise 1. Stand up your first cache and watch repeat requests go instant. Exercise 2. Hammer a cold cache with 100 concurrent requests, see the herd stampede, then flip on proxy cached lock and watch 99 of them politely wait. Exercise 3. Kill the backend and prove that use stale serves your last known good instead of a 502. Before you ship any of this, learn from 5 incidents that have burned real teams. 1. A set cookie on every response silently drops your hit ratio to 0. Fix it with proxy, ignore cache headers when the content isn't user-specific. 2. Stuffing user agent or raw query strings into the cache key shatters it into millions of unique entries. 3. The catastrophic one, caching authenticated responses without the session in the key means user B gets user A's bank balance. 4. No proxy or cache, lock on a hot URL, and one expiration takes down your backend. And 5. If you're not logging upstream cache your status, you're not tuning a cache, you're guessing. And that's lesson 2. 4 directives: cache path, valid plus a tuned key, lock to kill the herd, and use Drax stale for resilience. And your backend load drops by 95% behind a single shared zone. Next up, lesson 3. We take this exact same machinery and point it at FastCGI, so PHP requests never even reach the interpreter. WordPress from 50 requests a second to 5,000. See you there.